हेलो एवरीवन। जैसे कि आप लोगों को पता है कि मैं थर्मोडायनेमिक्स की प्रीवियस ईयर क्वेश्चन की सीरीज कर रहा हूँ। आज हम लोग इंजीनियरिंग सर्विसेज के क्वेश्चंस को देखेंगे। ओके, एंड द टॉपिक विल बी फर्स्ट लॉ ऑफ थर्मोडायनेमिक्स। ओके, आई थिंक आई हैव ऑलरेडी कंप्लीटेड 10 lectures. So if you are new on this channel, please watch those videos as well. Okay, so let's see today's question from engineering services. Okay, so what is saying in this question? This question came in IES 2001. Okay, so this table is given. Okay, so here the 4 processes is given और इसमें heat दिया हुआ है, but remember, see the unit, it is given in kilojoule per minute, and work is also given in kilojoule per minute. So they are asking what is the power. Okay, so okay, undergoing cycle. Okay, this is very important. आप इस चीज को याद रखिएगा। साइकिल अगर बोलता है तो फर्स्ट लॉ ऑफ थर्मोडायनेमिक्स में क्या होता है, dq इज इक्वल टू dw, मतलब जितना भी हम लोग हीट सप्लाई करते हैं सारा का सारा इट इज कन्वर्टेड इनटू वर्क. ओके, सो दिस इज नथिंग बट इज द फर्स्ट लॉ ऑफ थर्मोडायनेमिक्स. This application, this concept actually we have to use for this problem. Okay, we'll see. Okay, fine. So they are asking power. Okay, देखिए ये टेबल इतना दिया हुआ, हीट दिया हुआ, वर्क दिया हुआ है, बट हमें सारी चीज़ों की ज़रूरत नहीं पड़ेगी. ओके, सो व्हाट इज पावर. अगर देखिए हमें अगर वर्क पता है, ठीक है, सो देखिए किलो जूल पर सेकेंड, joule per second is what? Watt. I mean joule per second is watt. Okay, I am not saying that watt. So kilowatt is nothing but is the power. So अगर आपको वर्क पता है, अगर उसको आप किलोवाट में कन्वर्ट कर देते हो, दैट इज नथिंग बट पावर. तो हमें करना क्या है, देखिए हीट वाला यूज ही नहीं होगा इसमें. जस्ट कैलकुलेट द नेटवर्क. ओके, यू जस्ट कैलकुलेट द नेटवर्क. तो क्या होगा, जस्ट समेशन ऑफ ऑल दिस, और इन ऑल दिस प्रोसेस जस्ट ऐड ऑल दिस वर्क, यू विल गेट द टोटल वर्क. ओके, सो इट विल बी 474 प्लस 0 प्लस देन प्लस माइनस 180. सो इफ यू सिंप्लीफाई यू विल गेट 294 किलोजूल पर मिनट. ओके, नाउ इट इज गिवन इन मिनट, तो अब मिनट को कन्वर्ट कर लो सेकंड में. ओके, सो जस्ट डिवाइड विथ 60. ठीक है, 60 से आप डिवाइड करोगे यू विल गेट 4.9 वाट. ओके, सो द आंसर इज ए. ठीक है, तो इसमें हीट की जरूरत ही नहीं है. ओके, बस वर्क वाला जो दिया हुआ है उसी से ही आपका आंसर आ जाएगा. जस्ट कैलकुलेट द टोटल वर्क एंड डिवाइड विद द 60, यू विल गेट पावर. ओके, विल सी द नेक्स्ट क्वेश्चन. ओके, इसमें अगेन देखिए इट्स अ थर्मोडायनेमिक साइकिल. Okay, so the value of heat transfer and work transfer of 4 processes of thermodynamic cycle are given. So these are the 4 processes. Heat is given in kilojoule, work is given in kilojoule. So they are asking the thermal efficiency and work ratio of cycle will be respectively. Okay. Okay, we'll see how to solve this. देखिए इसमें थर्मल इफिशियंसी पूछ रहा है और वर्क रेशियो पूछ रहा है. ठीक है, देखिए थर्मल इफिशियंसी क्या होती है, वर्क डन बाय हीट एडेड. ठीक है, सो व्हाट इज वर्क डन, and work ratio is this. Okay, that's like summation of positive work minus summation of negative work divided by summation of positive work. So this is nothing but work ratio. Okay, so what is work done? Okay, so work done is nothing but like, okay, so we will take 300 minus 100. Okay, so this will be work done and heat added. What is heat added? So this is your heat added. So if you divide this, you'll get 0.66. Fine. Now for work ratio, just add the positive values. So this 300 plus 250 is 350, and add negative values, 100 plus 250 minus 350 divided by 550. So if you divide these two, you'll get 0.36. Okay, so the answer will be I think B. Okay, so you please remember this, because this kind of problem is very important. You may get in the exam, okay, like other exam like GATE or whatever exam you are targeting. Okay, next question. A tank containing air is stored by paddle wheel. The work input to the paddle wheel is 900 kilojoule, and heat transfer to the surrounding from the tank is 3000 kilojoule. The external work done by the system is, okay. So again, this is also like based from the first law of thermodynamics, we have to calculate. So actually, see here, we'll read the explanation, then we'll get the idea. Like, see, actually they are asking work done. So here actually the work done is done on the constant volume process. Okay, so what happened during constant volume process, like dW is equal to PdV. Since it is a constant volume process, so dV will be 0. Okay, so change in volume will be 0, so we'll get work done 0. Okay, so that's it. The answer is A. So this is a case of constant volume process or an isochoric process. Okay, as I've already explained that. Okay, so that the same thing they are saying. Performing work on the system temperature can be raised. In an irreversible constant volume process, the system does not perform work surrounding at the expense of its internal energy. Okay, so I've already told that P U is equal to PdV in case of constant volume process. So dV will be 0, so dW will be 0. Okay, see, I want to tell you one thing, like see, sometimes what happen in the exams, you'll get option as a 0. Okay, so if you know how to solve the problem, you can go ahead. Okay, if you don't know how to solve the problem, so what you can do, that you can simply tick the option which is 0. Okay, because 99% of time 0 will be the answer. Okay, I have found few questions, okay, as per my experience, only in few questions the answer is not 0. Okay, even in GATE exam also, I don't remember the year, maybe 2 to 3 years back, there was one question, so there also the answer was 0. Okay, so whether it is GATE exam or whatever exam, okay, if it is in the option 0 is given, you can blindly take the 0 if you want to attend that question. If you don't want to attend, you can skip that. Okay, if you if you know that how to solve that, you go ahead. But okay, most of time 0 is the option. You see, I'm not saying since I'm saying that's why you take the option, is up to you. If you want to take, you can take, because 99% of time that will be the answer. Okay, and if you don't want to take the 1% risk, don't take that. Next question. So now I think the question will be from internal energy. Let's read the problem. For a simple closed system of constant composition, the difference between the net heat and work interaction is identifiable as the change in. Okay, since it's we are already doing the internal energy, so obviously the answer will be the internal energy anyway, enthalpy, entropy, flow energy, internal energy. So here I told you, like, since we are dealing the internal energy, so the answer will be the internal energy. Okay, for a simple closed system, yeah, the difference between the net work and net heat and work. See, we have to use the first law of thermodynamics. What is first law of thermodynamics? dq is equal to du plus dw. Okay, so they are asking what is the difference between the heat and work. So you can say that dq is equal to du plus dw. So what is du? dq minus dw. Okay, so that is nothing but internal energy. Next question. Okay, we'll read the assertion reason question. The internal energy depends on the internal state of a body as determined by its temperature, pressure and composition. Okay, the internal energy of a substance does not include any energy that it may possess a result of its macroscopic position or movement. Okay, see, both is correct. Okay, both is correct, and this is also the correct explanation of A. Okay, so the answer is A. You can please read this explanation, is not much required. These two options itself is correct, so not much explanation is needed. Okay. Next question. Change in internal energy is a reversible process. In an irreversible process occurring in a closed system is equal to heat transfer if the process occurs at constant, okay, pressure, volume, temperature, enthalpy. This will be actually constant volume process. Okay, so this is the expression dq is equal to du plus pdv is nothing but first law of thermodynamics. Okay, when they are considering reversible process, okay, when they will consider reversible process, then we can write dq is dw is equal to pdv. Okay, so since it is like constant volume process, so dv will be 0, so we can say that dq is equal to du. So the same thing they are asking in the question, so in which case these two will be equal, so it is nothing but constant, it is a constant volume process, so the answer will be B. Next question. Okay, we'll read that. 85 kilojoule of heat is supplied to a closed system at a constant volume. During the next process, the system rejects 90 kilojoule of heat at a constant volume process, while 20 kilojoule of work done on it. Okay, so like different processes are given, for that heat and work is given. The system is brought to original state by an adiabatic process. Okay, the internal energy is 100 kilojoule. Fine. Then what is the quantity of work transferred during the process? Okay, so the whole process they are asking what is the quantity of work transfer. So there is total 3 processes. See, so this is nothing but these are the 3 processes. Actually, this will look like this. Okay, so they are asking for whole process what is the work transfer. Okay, so the for process this is 1, this is 2, this is 3. Okay, so the for process 1 and 2, okay, it's a constant volume process, so obviously dw will be 0, and heat supplied. Okay, heat supplied is given, that is 85 kilojoule, so it's like positive plus kilojoule. Okay, so see, here we have to actually focus on the sign convention. Okay, like when heat is supplying, whether it is plus or minus, since it is here is the plus. Okay, so if it is heat is releasing, so it will be negative. Okay, and if it is just reverse of this for the work transfer. Okay, so if it is like work is supplied, so it will be negative. If work is applied, it is positive. So something like that. So if देखिए किसी को अगर साइन कन्वेंशन नहीं पता है, ओके, इज़ वेरी सिंपल, मैंने ऑलरेडी बोल दिया है, ठीक है, बट मैं अभी कुछ दिनों बाद थर्मोडायनेमिक्स की कंप्लीट लेक्चर सीरीज लेके आऊँगा. दैट विल बी वेरी नाइस लेक्चर सीरीज. सो इफ़ यू आर वॉचिंग दैट, whatever problem you'll get for thermodynamics, you can attempt it. Okay, I will not say कि आप उसको correct करोगे, but I can damn sure you will attempt. Okay, so just wait for maybe 1 month or 2 months, when I will start getting extra time apart from my work. so I will start making lecture for that also. Okay, so as of now you focus on the questions, just do the questions, just wait for getting the complete lecture series. Fluid mechanics I have already started, so if you are new in this channel, please watch. I think 5 lecture I have uploaded, that will also I will cover when time progresses. Okay, fine. Now the second process is 2 to 3, so it is constant pressure process. Okay, so for constant pressure process it is given like system rejected heat of 90 kilojoule, so it will be negative. I told you, if it is like system, if heat is leaving from the system, it will be negative. And obviously the work done, constant pressure work done is this much, okay, 20 kilojoules, so this will also be negative. Fine. For this will be actually isothermal process. Okay, so the third one is will be the isothermal process. So okay, so for isothermal process dq will be 0. Okay, heat transfer will be 0. So they are asking what is the dw. Okay, so we know that now for all three processes what is the heat, and for two processes we know that what is the work done, but we don't know about third one, that they are asking. Okay, w they are asking for w3 to 1 they are asking. So now it is a closed system, this is a closed system. So what we have to do that we have to apply the first law of thermodynamics. What is first law of thermodynamics? dq is equal to summation of dq is equal to dw. Okay, so this like q, now we have to write, you know, q1 to 2 plus q 2 to 3 plus q 3 to 1. Okay, similarly w1 to 2, w2 to 3, w3 to 1. Now okay, from this equation, summation means हमें add कर देना है तीनों process के लिए. Okay, now put all the values here. Okay, you can see 85 minus 90 plus 0 plus 0 minus 20 plus dw. Okay, तीसरे वाले process के लिए हमें निकालना है. Okay, so this is the final equation. Now we have to solve for dw. You will get plus 15 kilojoule. Okay, so the answer is D. Okay, so देखिए ये question थोड़ा सा I will say it's complicated question because we have to take care of the sign convention. If you don't know the sign convention, कहीं पे भी अगर आपने plus minus छोड़ा तो you will land with any of the option, you apart from D, any of the option you will land. So that's why sign convention is very important. I will just repeat that. Okay, something like that. जैसे मान लो कि this is Q and this is W. Okay, this is W. So देखिए अगर मान लेते हैं कि सिस्टम से हीट निकल रही है, ओके, इफ इट इज निकल रही है तो निगेटिव हो जाएगा, और अगर सिस्टम में जा रही है हीट, दिस इज मान लो क्यू है, ठीक है, दिस इज ऑल्सो डब्ल्यू, तो दिस विल बी पॉजिटिव. ओके, तो सिस्टम को अगर हीट सप्लाई कर रहे हैं तो इट विल बी पॉजिटिव, अगर सिस्टम से हीट निकल रही है तो इट इज नेगेटिव. और इसका रिवर्स जो होता है, ओके, इफ इट इज रिवर्स देन इट इज just reverse of Q and W. I mean Q, it will be the W for the W. Okay, something like that. Okay, so like supplied, जब भी सप्लाई करता है तो it is positive, and जब उसमें से निकलता है तो नेगेटिव. और W में क्या होगा, अगर हम उसको अब सप्लाई करते हैं तो नेगेटिव होगा, और अगर निकल रहा है तो इट इज पॉजिटिव. Okay, so please remember this. Okay, so this is nothing but sign convention. Fine. तो देखिए मेरे कहने मतलब आप केवल एक याद रखो, जस्ट हीट का याद रखो. अगर आप सारा याद करने को चाहोगे तो यू विल आई थिंक कंफ्यूज कौन सा पॉजिटिव है कौन सा नेगेटिव होगा. तो मैंने क्या किया, आप किसी एक को याद रखो. जैसे कि सिस्टम को हीट देते हैं तो इट इज पॉजिटिव. ओके, तो निकलेगा तो नेगेटिव होगा, और जस्ट उसका रिवर्स वर्क के लिए हो जाएगा. ओके, जस्ट रिमेंबर दिस, यू विल नेवर डू मिस्टेक इन साइन कन्वेंशन. ओके, नेक्स्ट क्वेश्चन. अ क्लोज सिस्टम रिसीव्स 60 kilojoule heat but its internal energy decreases by 30 kilojoule then the work done of the system. इसमें फिर से वही फर्स्ट लॉ थर्मोडायनामिक्स है. ओके, सो dq इज इक्वल टू dw. यहाँ पे भी देखिए क्वेश्चन देखने में सिंपल है बट हमें साइन कन्वेंशन का ध्यान देना होगा. ओके, सो फर्स्ट रिसीव हीट. ओके, हीट रिसीव हो रहा है, इट मीन्स पॉजिटिव होगा. ओके, सो दैट्स व्हाई इट्स लाइक +60 और इंटरनल एनर्जी इज डिक्रीजिंग. डिक्रीज होगा तो ऑब्वियसली नेगेटिव होगा. ओके, सो जस्ट पुट हियर विल गेट 90 kilojoules. So the answer is A. Next question. Okay, we'll see that a system undergo a process during which the heat transfer of the system per degree increases in temperature is given by equation. Okay, so dq by dt is equal to 2 kilojoule per degree second. Now the work done of the system per degree increase in temperature is given by equation dw by dt is equal to 2 minus 0.1 T. Okay, so dw by dt is ऐसा लिख रहा है temperature. Okay, in degree centigrade. During the process, the temperature of water varies from 100 to 150 degrees centigrade. What will be the change in internal energy? ठीक है, देखिए dq by dt दिया हुआ है, dw by dt दिया हुआ है, पूछ रहा है कि what is internal energy. Okay, so कुछ नहीं करना है हमें, ऐसा बस ऐसा दिखाने के लिए complicated लग रहा है but it's like very simple question. We have to just use the first law of thermodynamics. That's it. Okay, so what is first law of thermodynamics? Is dq by dw. dq is equal to du plus dw. Okay, देखिए इतनी बार हम लोगों ने ना फर्स्ट लॉ को बोला है इस लेक्चर में. आई थिंक जो भी इस वीडियो को पहली बार देख रहा होगा, ओके, उसको तो हमेशा के लिए फर्स्ट लॉ याद हो जाएगा. सो dq is equal to du plus dw and summation of your total heat is equal to total work. देखिए अगर आपसे कोई पूछता है कि व्हाट इज फर्स्ट लॉ ऑफ थर्मोडायनामिक्स, तो आप ऐसा मत बोलो कि dq is equal to du plus dw. आपको बोलना है कि फॉर अ क्लोज सिस्टम, okay, net heat supplied to the system is equal to net work done. That is actually first law of thermodynamics. ये जो इक्वेशन है वो उसी से डराइव होता है. ओके, summation of dq is equal to summation of dw और summation of heat is equal to summation of work done. वहाँ से ये चीज डराइव होता है. So don't say like this equation dq is equal to du plus dw. Okay, so now so dq, अब इसमें देखो अब क्या करो, dt से पहले आप ये चीज देखिए. अब इसमें क्या करो कि इस dt को इस साइड लेते जाओ, यहाँ पे 2 इंटू dt कर लो, फिर यहाँ पे रख दो dq की वैल्यू, du, फिर dw इसको dt इधर लेके जाओ. ओके, सो dw इज व्हाट दिस. अब इसको इंटीग्रेट कर दो इस पूरे सिस्टम dq. अब इस चीज को इधर लेके आओ. ओके, सिंप्लीफाई करो. ओके, यू विल गेट 0.1 t, क्योंकि देखिए dt के टर्म में आ गया पूरा. अब इसको आप इंटीग्रेट कर दो 100 to 150. ओके, सो दिस इज ओके 100 to 150 विल गेट 625 किलोजूल. कुछ भी नहीं है. ओके, सिंपल क्वेश्चन. ऐसा बस लग रहा है कि कॉम्प्लिकेटेड है बट कुछ नहीं है. आप इसमें dq और dw की वैल्यू dt के टर्म में रखो, देन dq को एक साइड रखो, du को एक साइड लाओ, रेस्ट ऑफ थिंग को एक साइड करो, सिंप्लीफाई करो और जस्ट इंटीग्रेट फ्रॉम 100 to 150 विल गेट द आंसर. सिंपल इंटीग्रेशन है. ओके.